All right, I want to see if I can help out on Chapter 10, the two-sample t-tests and so forth that are discussed in that chapter. In Chapter 10, there are 1, 2, 3, 4, 5 tests that are described. One is the t-test with equal variances, or also called a pooled variance. Then there's a t-test with unequal or separate variances. There is a t-test of paired two-sample for means. And there is a z-test for the proportion, and a t-test for the differences, or f-test I mean, in the differences of two variances. So let's go through these real quickly. The t-test with equal variances, if the two populations that I'm trying to compare have the same or close to the same variance, then the t-test is a little simpler, and the calculation, the mathematics that drives that test is less demanding than the t-test for unequal variances. So we have to figure out whether our populations have equal or unequal variances. And when I say equal, I don't mean exactly equal, but I mean statistically equal, which is what the f-test does for us. Okay, then there's the t-test of paired two-sample for means. That's when you have to keep a category, a categorization, keep the data associated with a category. One example would be students. You might want to see if students take a test the first time and then the second time they get different instruction and they do better or worse the second time. You have to keep the test results connected to the categorical variable, which is the student's name. That is the two-sample for means test, all right, a paired t-test. Then the z-test for proportion. Fortunately, on proportions, you do not need a t-test. The z-test works for proportions, and it's fairly straightforward. I probably won't do one of these in this video. Okay, then there's the f-test for differences in two variances. So if I'm going to do a t-test, I need to know whether I have equal or unequal variances, and the f-test is how I do that. So basically what you need to do one of these and make sure you're going down the right path is to first check for normality of each of the data sets by doing a box plot or a normal probability curve, just to make sure the data looks somewhat normal. These tests are very invalid when the data is very, very not normal, just plots all over the place. Okay. Number two, if it's not a paired test or a z-test for proportion, then you have to do an f-test to see if the variances of the population are equal or not. That's what an f-test is for, and I'm going to show you in a second. And then you choose the correct test. And if you want to see a good roadmap for how to do all this, there's a roadmap on 1015. That roadmap is figure 1015 in the text, which is a great way to go down through and determine which tests you should be doing given the circumstances that you have. So you need to look that over and make sure you know how to quickly find that for when you're doing problems like these. Alright, so let's do an example. There's one in the book called COLA, C-O-L-A. We did want to see whether or not there's a difference between the two populations. Okay, so we need to do a t-test, but which one do we do? Do we do the one with separate variances, or do we do the one with equal variances? To answer that question, we have to do an f-test. We can do an f-test in PHStat, and there's also one, and I'll do this one here. There's also one here in the data analysis tool on Excel, f-test two-sample for variances. So I click that, and I put in my first variable range, which is this one right here. Put in that second variable range right here. And I did use the labels, so I have to click that. Now I could put this test wherever I want, so I'll pick the output range and I'll have them put it right there. That looks like a good spot, and I'll say okay, this is my f-test. Alright, I need to open up these columns so I can read them. Alright, there we go. Now the f-test is fairly straightforward. The f-test is always positive, never goes negative. The critical value for the f-test in this case is 3.179. And here's the bottom line on the f-test. If the calculated f right here is 2.23, if that were greater than the f critical, then we have unequal variances. If this number right here, the f number, is below the f critical, you have statistically equal variances. And that is the case here. We have a 2.23 compared to a 3.18. So therefore, statistically speaking, I have equal variances, and so I can move on now and use a t-test with equal variances to see whether or not I have populations that are equal or not. Okay, so my null hypothesis is that they're equal. I'm hoping that they're different. Okay, so let me go now to phstat, and we'll use it for my test on. I do a 2-sample unsummarized data. I do an pooled variance. It's called pooled variance, and that means the same thing. The hypothesized difference is 0. Level of significance 0.05. Got to put that first data set in there. Put the second data set in right here. And I'll say a two-tailed test and say OK. And I've just done my two-tailed test. And here's the bottom line: reject the null hypothesis. So I was hoping they weren't the same. That's why I picked the null hypothesis to be equal, the difference to be 0 between them. And it turns out that that has to be rejected. So that means what I was hoping to happen has happened. The alternative hypothesis is that these two populations are not equal. And when I say they're not equal, I mean in terms of their means. Their means are different based on my samples. So that's what the people that ran these tests on Nicola wanted to have happen, and so their statistics show that it has worked out for them. Now if I go back, I can look at what this looks like if I do a t-test using Excel. I would go to data, open that up, and look for a t-test in the Excel version, and that would be the t-test assuming equal variances right there. I'll say OK, and again put in my data. There's one. There's another one. And I did use the labels, and here I could put this somewhere on this sheet if I want. I'll put it right there. Okay, and there that is. And we should have got the same result. Now on this one here we have to do our own interpreting. They don't have the do not reject or reject on it like they do on the phstat, but it's not that hard to figure out. We were trying to do a two-tailed test. The p-value is low. The p-value is low whenever that number right there is below the level of significance, and the level of significance in this example is 0.05. So the p-value is low. The null must go. The null hypothesis was that the means of the two samples were equal. That has to be rejected. They are not equal. They are different. And like I said before, that is what the researcher was hoping to prove. Okay, so I hope this helps you out a little bit. The book presents the f-test last, but I believe the f-test has to be done after you do your normality tests. You do the f-test so that you can decide whether or not you're using equal or not equal variances for your t-test. Okay, so I hope that helps you, and I'm ready to answer questions in the forum. So just let me know if you need any help. Thank you.